Morning, friends. I am Dr. V.P. Anuja, Associate Professor of Mathematics, Arulmigi Palniyadar Arts College for Women, Chinnakalaimuthur, Palani. Today we are going to see transportation problem. The introduction of transportation problem is, it is a special type of linear programming problem where the objective is to minimize the cost of distributing a product from a number of sources to a number of destinations. Transportation deals with the transportation of a commodity from M sources to N destinations. It is assumed that level of supply of each source and the amount of demand at each destination are known. The unit transportation cost of commodity from each source to each destination are known. The objective is to determine the amount to be shifted from each source to each destination such that the total transportation cost is minimum. Types of transportation problems: balanced and unbalanced. Balanced transportation problem means both supplies and demands are equal. Unbalanced transportation problem means when the supply and demands are not equal. In this type of problem, either a dummy row or a dummy column is adding according to the requirement to make it a balanced problem. Methods to solve transportation problem are northwest corner method, least cost method, Vogel's approximation method. Using these three methods, we can find the initial basic feasible solution. Some basic definitions are: feasible solution: a set of non-negative values that satisfies the constraints is called a feasible solution. Basic feasible solution: a feasible solution to a transportation problem that contains no more than that m plus n minus 1 non-negative independent allocations is called a basic feasible solution to the transportation problem. Non-degenerate basic feasible solution: a basic feasible solution to a m cross n transportation problem is said to be non-degenerate basic feasible solution if it contains exactly m plus n minus 1 non-negative allocations in independent positions. Degenerate basic feasible solution: a basic feasible solution that contains less than m plus n minus 1 non-negative allocations is said to be a degenerate basic feasible solution. Next, optimal solution. A feasible solution is said to be an optimal solution if it minimizes the total transportation cost. The number of basic variables in an m cross n balanced transportation problem is at most m plus n minus 1. Next, we have seen the mathematical formulation of a transportation problem. Minimum Z is equal to summation I is equal to 1 to m, summation j is equal to 1 to n, Cij, Xij. Subject to the constraints, summation j is equal to 1 to n, Xij is equal to ai, where I is equal to 1 to m. Then summation I is equal to 1 to m, Xij is equal to bj, j is equal to 1 to n. Non-negative constraints, Xij is greater than or equal to 0 for all I, j. Here, this is the basic structure of transportation problem. Here, four sources are here: O1, O2, O3, O4. Four destinations: D1, D2, D3, D4. Supplies are denoted by S1, S2, S3, S4. Demands are denoted by D1, D2, D3, D4. Let us look into an example. Find an initial basic feasible solution using northwest corner method. Here, the sources are O1, O2, O3. Destinations are D1, D2, D3, D4. 300, 400, 500 are supplies. The demands are 250, 350, 400, then 200. Here, the total supply is equal to total demand. So, the given problem is balanced transportation problem. Okay, first we choose the northwest corner cell because this is northwest corner method. So, we choose the northwest corner cell. Okay, 3 is the placed in northwest corner. So, we find the initial basic feasible solution. First solution in this cell x11. x11 is equal to minimum of a1 comma b1. Here, the value of a1 is 300, b1 is 250. Minimum value of this is 250. We put this value in the first cell, 250. 250 is placed in first column. So, we cross the first column and subtract 250 from 300. The remaining element is 50. 50 is placed here. This is our first step. Next, the northwest corner places the cell x12. We find the initial basic feasible solution for this cell x12 is equal to minimum of S1 comma D2 50 comma 300. The minimum element is 50. We put this value in the cell x12. Subtract 50 from 350. The value is 300. 300 is here. The minimum element is in the row. So we cross the row. Next step, the northwest corner places x22. We have to find the initial basic feasible solution for this cell. x22 is equal to minimum of S2 comma B2 D2 400 comma 300. The minimum element is in 300. So we cross the second column. Subtract 300 from 400. We have to write 100 here. Next step, the next northwest corner places x23. x23 is equal to minimum of S2 comma D3. S2 value is 100 and D3 value is 400. Subtract 100 from 400. The remaining value is 300 is placed here. The minimum value is in the row. So we cross the row. Next step, the northwest corner places x33. We have to find the initial basic feasible solution for x33. Minimum of S3 comma D3. S3 value is 300. D3 value is 500. The minimum value is 300. Subtract 300 from 500. The remaining value is 200 is placed here. The minimum value is in the column. So we cross the third column. Next, last only one cell, x34. x34 is equal to minimum of S3 comma D4. Both the values are same, 200, 200. So, x34 value is 200. x200 is placed in this cell x34. Okay, now we calculate all the basic feasible solutions. And initial basic feasible solutions are x11 is equal to 250, x12 is equal to 50, x22 is equal to 300, x23 is equal to 100, x33 is equal to 300, x34 is equal to 200. The total transportation cost is equal to Cij into Xij. Using this formula, we get the value 4,400. Is the minimum cost of this transportation problem. Okay, we will see another example in our next class. Thank you.